So that is the first term in the D'Alembert's principle, Fy times delta Ri. Now let me take the other term, Pi dot times delta Ri, and see the expression that we can get from there. And then our aim is to combine those two at the end to derive the Lagrange equation. Now the second term of A is Pi dot times delta Ri now I can write Pi dot, so that's the rate of change of momentum, which is basically Mi times Ri double dot, and then delta Ri, we know that so first, for the first step, let me keep it as it is, and this is summed over I. Now for the delta Ri again, I can replace it from this equation right here, from equation 1.30. So the 1.12 delta Ri can be converted to generalized coordinates, which will give me summed over I and j Mi Ri double dot. Now the delta Ri is equal to dabba Ri over dabba Qj times delta Qj. Right, so let me name this as 1.16 and now consider the following relation. Consider the following relation. That is actually an expression for this term right here. So let me write it. If I consider the differentiation of the term Mi dot times dabba Ri over dabba Qj, I can differentiate this expression using the multiplication rule, that is sigma I. First I differentiate the first term, which is Mi Ri double dot then I keep the other term as it is, dabba Ri over dabba Qj and then minus, keep the first term Mi Ri dot and then differentiate the other term, so that is d over dt dabba Ri over dabba Qj. Right, now we have this term right here, So I can solve for that and find an expression which I can substitute into 1.16. So let me rewrite this expression. That is mi ri double dot daba ri over daba qj should be equal to sigma I d over dt so this should be plus actually, not minus, d over dt mi ri dot daba ri over daba qj and then minus mi ri dot d over dt daba ri over daba qj. This whole term. So let me name this as maybe 1.70. Term mi ri dot and then differentiate the other term. So that is d over dt daba ri over daba qj. Right. Now we have this term right here. So I can solve for that and find an expression which I can substitute into 1.16. So let me rewrite this expression. That is mi ri double dot daba ri over daba qj should be equal to sigma I d over dt so this should be plus actually, not minus, d over dt mi ri dot daba ri over daba qj and then minus mi ri dot d over dt daba ri over daba qj. This whole term. So let me name this as maybe 1.70. Right, now take this term right here, which is d over dt daba ri over daba qj and let me interchange the dt and daba qj and see what we get. That is daba over daba qj. So what I am doing here is interchanging the differentiation with respect to t and qj, and then I have d ri over dt, and that is d ri over dt means ri dot So I get dabba ri dot over dabba qj. So this is ri dot. Now ri dot means actually the velocity, which means dabba vi over dabba qj. So we basically can substitute this expression from dabba vi over dabba qj in our next step. Right, so the next step is to replace this expression right here. So we can substitute that using an expression which we can derive from the equation for vi right here from 1.11. so that is an expression for vi. So let me write or differentiate this 1.11 which is the expression for vi with respect to qj dot. So let's see what I get. So expression 11 from 11, so I can write or differentiate the expression for vi with respect to qj dot, and this will give me the first. Let me go back and see the expression. So the first term, when you differentiate with respect to qj dot, you will have only the term jth term. So the k will be replaced by j, and this summation is so will just become dabba ri over dabba qj. So the answer would be dabba ri over dabba qj. Because what happens here is, if you look at this expression right here, so you just differentiate with respect to qj dot, which is, if you expand the summation, only the jth term is what we need, and qj dot differentiated with respect to qj dot will give you this dabba ri over dabba qj term. So that will be the only term that is remaining, because all the other things will be considered as constant with respect to qj dot. So this is what we get, and from this I can now substitute this expression. So I have this expression which I can now take back and plug in 1.117. So instead of dabba ri over dabba qj, I can substitute dabba vi over dabba qj dot. Right? So if I take, let me take this as 1.18 and this as 1.19. Plug those two values in 1.17. So that is, so let me write it here. Substitute 1.18 and 1.19 into 1.17. So we will get sum over I mi ri double dot dabba ri over dabba qj equal sum over I d over dt mi. Now this ri dot is the velocity, so that I can replace it by vi, and then dabba Ri over dabba Qj can be replaced from this term right here, dabba Vi over dabba Qj dot, this whole thing inside the brackets, and minus MIVI dabba Vi over dabba Qj. Right, so the dabba Ri over dabba Qj is replaced from dabba Vi over dabba Qj. So this is the complete expression. Right, so now I have an expression for MIRI double dot times dabba Ri over dabba Qj, so that I can take that expression and plug it into the very first step I had here, which is 1.16. So what I would get is in 1.16 you have the summation over j with, and then this term should go into that, so that will be d over dt and so this term right here, now you can write it as the kinetic energy term, or half because it can be written as dabba over dabba Qj dot half Mi Vi squared. Right, so if you differentiate with respect to Qj dot, you get MIVI, and then you differentiate Vi with respect to Qj dot, so you will get this answer right here, right? So it's the same. And then in the similar fashion, I can write the other term. Now combining 1.15 and 1.16, or this term right here, now you can write or rewrite the expression A, which is the D'Alembert principle, using these new terms. So first of all, you have J d over dt dabba over dabba Qj dot, and then sigma I half MIVI squared. This is one term, and then minus dabba over dabba Qj I half MIVI squared minus the other term now we have, which is Qj, that comes from the second term of the generalized force, and times delta Qj. This is what we get at the end. Now I can write this term as the kinetic energy, right? Half mi Vi squared. So this will be the kinetic energy of the system, and this will be the kinetic energy of the system as well, which means I can write this whole expression summed over J d over dt double T over double Qj dot minus double T over double Qj. And then minus the generalized force Qj times delta Qj equal to 0. This is actually the section that I was discussing last time in the lecture. So if the note is not clear in that time last week, just go through this note and you will, rest of the things you can figure out. Just go back to the note and look at what I have done after this, so that you will easily understand the whole procedure for the proof of Lagrangian equation. So as we did in the class last time, what you need to do after here is write the force or the generalized force as double V over double Qj, assuming V is the potential function, and then substitute it into Qj, and then rewrite this equation so that you will get the Lagrange equation from there, right?